Hi guys, welcome back to Scratch Skills. In today's video, we're going to be checking out Unit 4 of AP Computer Science A, and this is part 1, because this unit, data collections, is such a big unit. It covers 30 to 40% of the examination. Starting with datasets. Dataset is a collection of information of data, and loops are used to process through the datasets in Java. Loops matter because Java cannot process all of the table or dataset at once. One type of a dataset is an array. An array is a collection of elements of the same type stored in one variable. It helps us store many values together and access them using the index. Now, in contrast, we had normal variables and some variables where we can only store one value. So we would say int score 90 and that's it. So arrays can help us store many values. To create an array, we have to write the data type, square brackets, name, equals to, in curly brackets, all the data it has. Now, if I convert this line code into a visual, it would look something like this. So there would be a table from 90 to 95, and the index values would go like 0, 1, 2, 3, and 4. If we create an empty string like int data type scores equals a new int and we don't know the value, then by default, if it was an int, it would have 0, double 0.0, boolean false, and a string would be null. Here is what I was just talking about in the thing: data type, array name, new data type size, data type, array name, values. Accessing and modifying elements would be by using the indexes. So 0, 1, 2, 1 will be 85 because over here, and if I'm going to set 2 is equal to 95, that would set 100 to a 95 because that is index 2. The length of an array is just scores dot length, no parentheses. Now, how do I transverse through this array? It's like visiting every element in the array. Mostly people use for loops, and this is the most common one. It's really easy to write to. This is just a basic for loop thing. If you have doubts with loops, then please go watch Unit 2's video, because I go in detail over that over there. So for int I is equal to 0, I is lesser than array length without the parentheses, and it just keeps going. So it would just keep going from 0, 1, 2, 3, 4. Now the array length over here is 1, 2, 3, 4, 5. And since it's not equal to 5, it stops right before 5, which is 4, which is perfect. The next is an enhanced for loop, and this we cannot modify anything inside the array, we just transverse through it. So that is going to be int value, which would be the index value, and this is array. It just goes through each value. For each value in the array, it prints out the value. Next is a while loop. This is not that popular, but it's really simple. So we have int I is equal to 0, and then transverses through it and just keeps adding on I until it reaches 4. Next, we have searching practice. Now, just using your common sense and what you have now, just try to write something like this. It's a linear search where we're searching for a target value, so you transverse through the array, and then if you find the target value, then you return the index of the target value. If not, you return -1. So I'm hoping you pause it and find it in your IDE and write it down. So if you did, great. If you didn't, that's fine too. So over here is the answer. So we're transversing through a for loop, and inside the for loop we have an if loop just stating if the current index is equal to the current value in the index I is equal to the target, then we get the index value, otherwise we get a -1. Now, patterns, things that instead of just looping through arrays, we can learn common patterns and algorithms you reuse in exams and FRQs. These are common in general. So the first is the accumulator pattern. This is an enhanced for loop. Just go through each value in the for loop. Then we have the average true over here, which is the sum minus the total number of things in the array. And then we have the max and min. So min's going to be equal to the first one. Just keeps going. We have a for and an if loop. And this is for min. And if we want a max, we would do the same thing, just the crocodile mouth to the other side. Next is the search linear, which we actually just did. Fairly simple. And this is for any duplicates when we're searching for any duplicates. So this is actually a nested for loop, because first we're going to check 1 if, and then we're going to go through every loop, and if 1 is there, then it just returns true. Then it goes to 2, checks 1, 2, 3, 4, any 2s, it returns 2. This is how this one works. And those were the common types. Next we have input files. The first input that we already learned is the user input that we use the scanner to get. This is how we write it: the class name, new input scanner, and then the parameter from the system. Now that we have a file, input files, we do the same with new file and the data, like the name of the file over here. New file, name of the file. Another thing that we notice is an IO exception. So if the file is not found, it handles. Now a code to explain all of this is, first make sure you import the IO for the throws IO exception, and you have the java.util import everything from the library, which is just these asterisks. And now the first line over here, we would say throws IO exception is what's added, and this says if the file can be found, just stop it safely instead of crashing randomly. And then we have the line we were just talking about over here, the new file one. So we would have file, my file, new file, and data is the file I want. So that's the file I want. And to start reading the file, I would have the scanner. This is the file and the scanner. And then to go through the file, we would have a while loop over here with things, with just checking if it has something next, and then printing it using the next line, which we learned in the scanner input. And then we have scan.close, which stops reading the file. Now in detail, for the while loop, if it was a string, we would use next line. If it was an int, we would use next int. If it was a double, next double. And if it was just like next word or next token, we would just use has next, which is the most common one. So over here, make sure you have this always together, so don't mess that up. And then we have reading the data from the files. Now most data from the files will come out as strings, so next line and next is the most important ones, but you should know that there are next in and next double too. Splitting the data. Splitting the data from when we're reading a file, things in a file is usually split using commas. So I would just write string. I would create a string line over here, and it just goes through everything, and then string parts is equal to the line dot split at commas. So it splits the thing at commas, and part 0 would be Alex, then 90, then 2 would be 85, Mia would be 3, 4, 5 over here. Like that. If I had backslash over here, I would just change the comma for a backslash. Next is wrapper classes. From the primitive types, int, double, and boolean, we can change them int and booleans to wrapper classes, which is an object, because Java just needs objects sometimes instead, because they're more complex and we can actually have useful methods and adding of stuff added to them. So to make a wrapper class, we would just name them integer x is equal to 5, not int x is equal to 5. Same goes for double. Now parsing merge. Now this is what I was talking about when I say file input usually reads the files as strings. So string age would be 16. If I wanted to add 10 to the age, it was just going to be 16 and 10 using concatenation. But then the parse int actually turns the input from the file as strings to a number. So 16 turns into 16 as a number. Then we can actually add, giving us 26. Same goes for decimal over here. 2.5 in quotes would be just 2.5. A full file example over here would be if it has a next line, then it goes through the next line, and then it splits at the comma, and grade would be the first one. The integer parse int would just convert the grade if it was a 90 to a 90 without quotes, and it would just print out 90. Overflow is just something you should know for MCQs. That is, the max value is that value over there, and if I add 1 to the value, it's not going to go up because that is the max value. There's nothing over that. It's going to actually go back down all the way and give us the negative version of that number, because it's like an odometer just rolling around. Now that was it for part 1. Part 2 will have much more. I hope this helped, and part 2 will be uploading in a minute. Thank you, bye!